Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome to my channel Jojo's Learning Club. So after a long pause, I thought like I wanted to do YouTube again. So I started now with a new topic and now I will be dealing with electronic device circuits. Earlier I was dealing with Max, now my interest is on electronics, so I thought I will do work problems and also theory and basics, everything regarding electronic devices. So my first topic will be on electronic device circuits. This will be also helpful for your gate preparation, or you just wanted to learn about electronics, or for your 11th and 12th just to understand the basic of all the electronic devices. It would be really helpful. So first, before starting electronic device and circuits, first let us understand what is temperature. So first we are going to say, now when we are saying about temperature, now we are going to say about in Kelvin. So first, in temperature we learn about is absolute temperature. What is absolute temperature? Absolute temperature is like 0 Kelvin. When we write in degrees Celsius, it is how much? Minus 273 degrees Celsius. And it is also called the reference temperature. Why it is said as reference temperature? Why? Because below it no temperature exists and no device work at this temperature. So that is why it is called absolute temperature. Now let's see what is a room temperature. Room temperature is regarded as 300 Kelvin, which is equivalent to 27 degrees Celsius. And you will often deal with problems where it is not said about the temperature, so where the temperature would not be given. So what it means, it is by default 300 Kelvin or the room temperature, that is equivalent to 27 degrees Celsius, or mostly when you do problems related to electronics, so it will be in Kelvin, so you can substitute for temperature as 300 Kelvin over there. And the next topic would be ambient temperature. Ambient temperature is like 290 Kelvin, which is equal to 17 degrees Celsius. What is that? It is also called as the surrounding temperature. All common systems deal with ambient temperature. One of the example is SNR. And next we will deal with temperature conversion. So we learned about what are the different types of temperature, right? So what are the different types of temperature? Absolute temperature, room temperature, and ambient temperature. These are the most important types of temperatures which are required while dealing with problems related to electronics. So let's also understand. So if any other temperature is given, you wanted to do a conversion. So what you'll do, you'll come with a temperature conversion. For that, first you take temperature in degrees Celsius. So temperature in degrees Celsius, when it is given, if a temperature in Kelvin it is given and you wanted to find the temperature in degrees Celsius. So what you will do, you will calculate the temperature degrees Celsius is equal to the given temperature in Kelvin minus 273 will give you the temperature in degrees Celsius. And what about temperature in Kelvin? Temperature when it is given in Kelvin, what you will do it? So temperature in degrees Celsius plus you do a 273, that will be equivalent to the temperature in Kelvin. And let us understand some notations. 0 Kelvin and 0K or Kelvin. OK or 0K, it was the old notation for the Kelvin, and nowadays the Kelvin is just written with the notation K. Similarly, another one notation for frequency is cycles per second. That was the old notation for frequency, but nowadays it is represented in terms of hertz and it is written in H small z. Okay, so now that's all about temperature, and let's now come back with thermal voltage. So you have always seen while solving problems, right? What is thermal voltage? So thermal voltage is denoted by Vt, that is V small letter t, or V capital T, or Vth. So these are all thermal voltage. So what is actually thermal voltage? So this is the voltage equivalent of temperature. Don't worry about now to understand what is a thermal voltage. When we are going to the basics of semiconductors, obviously thermal voltage will come again, and I will give a brief introduction to thermal voltage. So for the time being, just understand that thermal voltage is nothing but it's a voltage equivalent of temperature. So Vt is equal to K dash T by Q. What is the difference? Why it is K dash? That is also coming in now in the down. So T is where T is the temperature in Kelvin, K is the Boltzmann constant, K dash. So Boltzmann constant, either you can represent it in terms of electron volt per Kelvin or joules per Kelvin. That is, here K dash is given in terms of joules per Kelvin. That is 1.381 into 10 raised to minus 23 joules per Kelvin. And K in terms of a Boltzmann constant in terms of electron volt per Kelvin is equal to K equal to 8.62 into 10 raised to minus 5 electron volt per Kelvin. Okay, so now we know what was the equation? Vt is equal to kT by Q. I hope you remember. So from that, Vt is what? Equal to T by 11,600 volts. So from that, we know that you can see by seeing the equation what it is. Vt is directly proportional to T, right? So whenever there is an increase in temperature though, so what happens? There will be also increase in thermal voltage. So at what now we'll find a temperature equal to 0 Kelvin. So what will be the thermal voltage at 0 Kelvin? Just substitute here 0. So what is it? 0 by anything? 0. So what is this? Thermal voltage is equal to 0 volt. I didn't write here 0 volt, but actually it is 0 volt. And next, temperature equal to 300 Kelvin. So what it will be? Vt is equal to 300 by 11,600, which is equal to 0.025685 volt, which is equivalent to around, just we are rounding off, so and we can write it as 26 milliwatt at room temperature. So for large variation in temperature, that is around 0 to 300 Kelvin, there will be a small variation in thermal voltage. What it will be like when it is increasing from 0 to 300 Kelvin? So what thermal voltage will? Thermal voltage will increase from 0 to 26 milliwatt. And next, also we'll learn what's about next about electron volt. Before that, one more point about temperature. Semiconductor devices are sensitive to temperature very much. Yeah, there are a lot of functions which changes when in a semiconductor temperature is increased. You will learn more about it. Don't worry about this now. Just understand semiconductor devices are sensitive to temperature very much. And let's now go on to the electron volt. So what is an electron volt? Electron volt is defined as the energy gained by the electron in moving through a potential difference of 1 volt. So what is electron volt? It is defined as the energy gained by the electron. So when an electron is gained energy in moving through a potential difference of 1 volt, it is called the electron volt. So 1 electron volt is defined as the energy gained by the electron in moving through a potential difference of 1 volt. So its practical unit of energy in electronics, and it is very small compared to joule. So now you'll in Boltzmann constant, when you were dealing, you saw the Boltzmann constant written in terms of joules and also in Kelvin. So now we'll get a relation in the later. And next, let's learn two more points. So what is air? Air is always a perfect insulator and vacuum is a conductor. For example, vacuum tube, picture tube, CRT, etc. Next, let's learn about relative permittivity. Epsilon R of air is approximately equal to 1 or slightly greater than 1, and if a vacuum is equal to 1. So what is permittivity? Just to understand, permittivity is a property of material that measures the opposition it offers against an electric field. So what it is actually, it's an opposition against the electric field. Now 1 electron volt is equal to Q into V. So now I told you, right, we are going to write the electron volt in terms of joule. So how do you convert? In the earlier equation Boltzmann constant, you just saw it was directly written, but how did you get, how did you convert 1 electron volt into joule? 1 electron volt equal to, so what it was, 1 electron volt, it is defined as the energy gained by the electron in moving through a potential difference of 1 volt. So Q into V. What was Q? Charge. 1.6 into 10 raised to minus 19 coulomb into 1 volt, which is equal to 1.610 into 10 raised to minus 19 coulomb volt, or you can say it as a joule. So 1 joule energy can be applied to electrons because of very less capacity. For let's say kinetic energy equal to half mv square and potential energy equal to qvj. Electron volt indicates the amount of kinetic energy gained by the electron or the potential energy lost by the electron. That is another one definition for electron volt. So what it is? Electron volt is indicated as the amount of kinetic energy gained by the electron or the potential energy lost by the electron. So what we can see, what is the amount of kinetic energy? Kinetic energy is equal to half mv square, and potential energy, that is like qv. From that you can solve the velocity of electron, which is equal to v equal to root of 2 into 2. It is not g, it is q, sorry. So I have to do it a correction. Let me do a correction in it. Yes, I'll do a correction in it. Okay, and now let me do the correction to qv by m. Okay, so now the equation is correct. Okay, now let's go back to the equation. Meter per second, sorry. So it is the equation for the velocity of electron in terms of applied voltage. So I hope till now we have covered about what all topics we covered today. We covered about temperature in detail, then we covered about the thermal voltage, then we did also understand about the electron volt. And on my next topic I'll start with electric field intensity. Okay, so that's all for today's video. Thank you for watching the video. See you on my next video. Bye bye.